Hubble tracked Oumuamua for weeks in late 2017, and the orbit didn't match the model. The object was speeding up on its way out of the solar system. Comets do that when sunlight boils ice off their surface and the escaping gas pushes back. But no Coma showed up in any exposure, no dust trail, no gas signature. The acceleration was real. The mechanism was missing. The survey that found it was Pan-STARRS, a telescope built to catch asteroids that threaten Earth, scanning a fraction of the sky each night. Oumuamua crossed that fraction by chance, already past its closest approach to the sun, already fading. By the time anyone confirmed it came from outside the solar system, the best data window had closed. Every argument that followed was built on a target that was already leaving. The shape estimate came from the light curve, the way its brightness rose and fell as the object tumbled. The swing was extreme, consistent with something 10 times longer than it was wide. No confirmed solar system object looks like that, but a light curve isn't a photograph. It's a brightness pattern run backward through a model, and the model allows more than one shape. A flattened disk fits nearly as well as an elongated cigar. That's the first clue, an acceleration with no visible cause. The second is a shape estimate built entirely on inference, not resolution. The boring answer came first. Outgassing from exotic ices, molecular hydrogen or nitrogen, could push the object without producing a visible dust coma. The chemistry was speculative, but it kept the comet explanation alive. It explained the acceleration. It didn't explain why no version of that outgassing showed up in any spectrum Hubble or ground telescopes collected. So the workaround was statistical, not observational. Researchers modeled how much outgassing would be required, then checked whether that amount could stay hidden from every instrument pointed at it. Some models passed, others didn't. No single result closed the case, because the data density was too low to rule out the exotic comet explanation or confirm it. Every path led back to the same wall. Too little time, too few photons, too narrow a field of view. Pan-STARRS was never built to characterize interstellar objects. It was built to find asteroids early enough to matter for planetary defense. Oumuamua was just a byproduct of a search designed for something else entirely. Borisov changed the comparison 2 years later. A second interstellar object, this one with a visible coma, standard comet chemistry, a dust tail behaving exactly as sunlight and ice predict. Borisov didn't resolve Oumuamua. It sharpened the contrast. One interstellar visitor behaved like every comet in the archive. The other didn't behave like anything in the archive. The wider question stopped being about one object. It became a question about instrument coverage. If Oumuamua's strangeness came from real physics, an object type never seen before, that mattered for how solar systems eject material and how common interstellar wanderers are. If the strangeness came from insufficient data, that mattered just as much, because it meant the same blind spot would come back with the next object, and the one after that. The uncertainty is the point. A stronger claim about Oumuamua's composition, shape, or origin would need dense photometric coverage from the moment of detection, ideally before closest approach, with spectroscopy sensitive enough to catch faint outgassing signatures. That data was never collected, because no survey running in 2017 was built to collect it. The Vera Rubin Observatory changes the coverage problem directly. Wide field, fast cadence, repeated scans of the same sky every few nights. Rubin is expected to catch interstellar objects earlier in their approach, while there's still time to schedule follow-up before the object leaves detection range. Projections suggest Rubin could find several interstellar visitors over its survey lifetime, instead of one every few years by accident. When that happens, the test becomes real. If the next interstellar object also shows unexplained acceleration with no coma, The anomaly moves from a single ambiguous case toward a pattern, evidence about the object class, not the telescope. If it behaves like Borisov, the case for something unusual in Oumuamua's specific history gets harder to defend, and easier to file as the shape a limited instrument gives a fast-moving unknown. The file stays open, not because the mystery demands wonder, but because the measurement that would close it was never taken. Whatever crossed the solar system in 2017 is gone, still accelerating, still unreachable. The next one is the one Rubin is waiting for.